Now let's look at how we can find the order of a point on an elliptic curve. Remember that the order of a point is defined to be the smallest integer n, so the smallest positive integer n, so that n times p is equal to 0, the point at infinity. So to find the order of a certain point, we're going to add it to itself until we get 0. The smallest number of times we can add it and then get 0 is going to be the order. So as our first example, let's use the curve y squared equals x cubed minus 219x plus 1654. And let's find the order of a couple of points. First of all, we're going to find the order of the point 3, 32. Now, one thing that I'd like to remind us is that we can use the shortcut formula that says that the third point of intersection of a line passing through the curve is going to be the square of the slope of the line minus a from this equation minus x1 minus x2, where x1 and x2 are the x-coordinates of the two known points. Now this one's kind of a special equation because there's no x squared term in it. So for this equation, there's no a, and my shortcut formula takes the form m squared minus x1 minus x2. So let's work with p. Now first of all, we want to find 2 times p, which is the same as p plus itself. Now remember, when you want to add a point to itself, we have to use a tangent line. So here's our point. We need to find the tangent line to the curve at this point, and we want to find out where that curve crosses the, where that tangent line crosses the curve again. Using implicit differentiation, we have 2y dy dx is equal to 3x squared minus 219. So dy dx is equal to 3x squared minus 219 divided by 2y. So in particular, at the point 3, 32, the slope is going to equal 3 times 3 squared minus 219 over 2 times 32. And if you simplify that, you get negative 3. Now, if you want to, you can go ahead and substitute this and 3 twice into this formula to get x3. But let's go ahead and find the equation for the tangent line. That'll allow us to get the y-coordinate. Y is equal to, y minus y sub 1. So y minus 32 is equal to the slope, negative 3, times x minus 3. So y minus 32 equals negative 3x plus 9. So the equation for our tangent line is y equals negative 3x plus 41. So now let's figure out what the third point of intersection is when I intersect this tangent line with that graph. Using this formula, x sub 3 is going to be the slope squared, which is negative 3 squared, minus x1, which is 3, minus x2, which is also 3, which is 9 minus 6, or 3. To get the y-coordinate, we substitute into the equation for the tangent line. That's negative 3 times 3 plus 41, which is equal to 32. So that means that p star p is equal to 332. Well, that's kind of interesting. That's the same thing as p. That tells us something about the graph. That tells us actually that p is a point of inflection of the graph. So the tangent line actually has contact of order 3 at this point. Now remember, to get y3, you need to reflect across the x-axis. So p star p is the same as p. then P plus P is going to be the reflection across the x-axis, and that'll be at negative 32. So P plus P is 3 comma negative 32. So what we have so far is that if P is 332, then 2P is 3 negative 32. Now let's figure out what 3P is. 3P is P plus 2P, which is going to be 332 added to 3 negative 32. In other words, I want to add this point to this point. Well, those 2 points lie on the same vertical line. And we said that when we have 2 points on the same vertical line, their sum is 0. So 3P is 0, the point of infinity. Therefore, the order of point P is 3.